Last time, I told you how a failed pen test in 2016 led me to OWASP, to HTTP security headers, and to building an ASP.NET Core middleware to fix that problem. What I didn't tell you is what happened next. Because having working code on your laptop and having a NuGet package that's been downloaded 1.7 million times are two very different things. This is the story of the journey between. And it's a story about everything I had to learn on that journey that nobody had ever taught me. Hey everyone, and welcome back to the Modern.NET Show, the premier .NET podcast focusing entirely on the knowledge, tools, and frameworks that all .NET developers should have in their toolbox. I am your host, Jamie Taylor, bringing you conversations with the brightest minds in the .NET ecosystem. Today's episode is a little different from the norm. I wanted to temporarily take you away from the AI is the best thing ever / worst thing ever news cycle and talk about an open source project that I work on called OwaspHeaders.Core. This is the second in a two-part series about OwaspHeaders.Core and focuses on providing a timeline of the evolution of the package. But this isn't going to be all about how great I am. I'm going to cover the lessons I learned, the choices I made, and the help that I had from the community along the way. Before we jump in, a quick reminder. If the Modern.NET Show has become part of your learning journey, then please consider supporting us through Patreon or Buy Me a Coffee. Every contribution helps us to continue bringing you these in-depth conversations with industry experts. You'll find all the links in the show notes. So let's sit back, open up a terminal, type in .NET New Podcast, and we'll dive into the core of modern.NET. So, around the same time as the Pentest story I told you about in the last episode, Microsoft were doing something that felt unimaginable a few years earlier. They were rebuilding .NET. Open source, cross-platform, a version of the framework that I'd grown up on can now be run on a MacBook Air. I was completely fascinated by it. And I made what felt at the time like a very small decision. I started a blog. I called it A Journey in .NET Core. The title was very deliberate. I wasn't an expert, and I wasn't going to pretend to be one. The point was that I was going to try and figure this thing out in public and write about what I learned along the way so that anyone else walking the same path could trip on the same things and maybe get past them a little quicker. The blog isn't live anymore, by the way. I took it down in 2023. The full content is on the Wayback Machine if you know what to search for, and I've got plans to revive it as an archived site at some point. I'll link to the Wayback Machine version in the show notes. Anyway, back to 2017. One of the few things in ASP.NET Core was the middleware pipeline, and I wanted to write about it. I wanted to take leaders through how it worked, what you could do with it, how you'd build your own. And I needed a concrete example to hang the explanation on. The Pentest story was still fresh. The OWASP recommended headers were the thing I'd most recently learned how to do well, so that became the vehicle. A 4-part blog series walking readers through building a custom ASP.NET Core middleware that would add the OWASP recommended security headers to any response that went through it. My first post went up in July 2017. By the time I'd finished part 4 in September, the middleware genuinely worked. It even had tests, the whole shebang. I'd shipped a real thing in public showing all of my working out. And then I had a thought. A thought that, looking back, was actually the turning point. The thought was, hang on, if this middleware is useful, then anybody who wants to use it has to read 4 blog posts, copy out code from them, paste it into their project, and hope they didn't miss anything, or more importantly, that I didn't miss anything. That's a fair bit of friction, and even more so now that the blog is harder to access. That's the kind of friction that means almost nobody will actually do it. So why didn't I just make a NuGet package? Wrap it up, make it one line of config in someone else's project. That way, the only thing they have to do is type .NET add package and the whole thing is there, ready to go. I had no idea what I was about to walk into. Here's the honest truth. Before I tried to ship my first NuGet package, I'd never thought about what a NuGet package actually was. I'd consumed hundreds of them. So have most .NET developers. When you type .NET add package, something happens behind the scenes, and now you can call into a library that you didn't write. That's the whole interaction for most of the time. But what is this thing that was just added? The short version is that a NuGet package, which is a .nupkg file, is essentially just a zip file. Open one with 7-zip or your favorite archive utility, and you can see the structure. There are some compiled DLLs in there. There's an XML file with metadata. There's a license. There's an icon. There are bits and pieces that the package management tool reads in order to make decisions about how to wire up the dependency into your project. Scott Harden and I actually spent the best part of an episode on this in Season 7, Episode 9, which is called Modern.NET NuGet Packaging with Scott Harden. We pulled apart the structure of a real package layer by layer. If you want the deep dive, that's where to go to. There's a link in the show notes. Back in 2017, 6 years before that episode was recorded, I went from knowing none of that to having to know it well enough to publish my own NuGet package. And the things I had to learn to get from one end of that journey to the other came in roughly this order. First, the CS_proj metadata. These are the properties that show up on NuGet.org. The description, the author, the license expression, package icon, project URL, repository URL, release notes, all of those live in the CS_proj file as MS-build properties. Get them wrong, and the package still builds, but it just looks unprofessional on the listing page. And first impressions, when somebody's deciding whether to trust your package or not, matter more than you'd think. Second, semantic versioning. I'd been using version numbers as fairly arbitrary labels up to this point. The first time I had to decide whether a change was a patch or a minor or a major version bump, I sat staring at the screen for an embarrassingly long time. I'm being honest, because once you publish that version, the contract you've made with everyone who depends on you is real. A major version bump says, I've broken something on purpose. A patch says, nothing about the surface area has changed. Choosing wrong is the kind of mistake that costs other people their afternoons. Third, the account setup. Generating an API key on NuGet.org, working out which scope it needed, storing it somewhere that wasn't just a screenshot and Twitter, all of that. Also, don't store anything like that as a screenshot on Twitter. I was being a bit silly. And fourth, the actual mechanics. Building the package, pushing it to NuGet.org for the first time, watching the validation process, waiting for it to appear on the listing. The first time you see your own thing live on NuGet.org is a properly memorable moment. Wish I'd taken a screenshot. None of this was taught to me. I'd learned by doing, by reading documentation and by getting things wrong in public. And the documentation on NuGet and on learn.microsoft.com is genuinely good. It's better now than it was when I started, and the tooling has only improved. So here's the thing I want you to take from this episode. If you've solved a problem in your own codebase that other developers are likely solving too, the barrier to publishing that as a NuGet package is much, much lower than you probably think it is. But here's the other half of the lesson, and I think this is the part that doesn't get told too often. The barrier to publishing a package you won't be embarrassed by in 6 months is higher. Let me tell you a story about that. The first version of OwaspHeaders.Core used a JSON config file. The settings, which headers to include, what values to give them, all of it, lived in a file called secureheadersettings.json sitting in the consumer's project. And I'd helpfully configured it with reload on change set to true, because that's the default. That's what you'd expect. Do you see the problem approaching? If a big application was serving real traffic and somebody changed that JSON file on disk, the whole site would restart. The middleware would reread its config and ASP.NET Core would cycle the application along with it. Disastrous. I shipped that and people were using it. So in February 2018, I rewrote it. The configuration moved out of a JSON file and into a builder pattern. You wire up the middleware in code at startup, and the configuration is baked in at the point your application boots. No file watcher, no restart on change foot gun. It's how the package has worked ever since. That whole rewrite, the realization, the redesign, the migration path for existing users, happened in public on my blog and partly on a live stream, because that's how I was working at the time. And because of that, the version where I shipped the bug is part of the story. Barrier to entry is low. The barrier to shipping something you'd defend in front of a room is higher. But you only get to the second one by being willing to be wrong in front of people. That's the whole game. Once you've published one version of a NuGet package, you very quickly realize that publishing the next version manually from your laptop isn't going to scale. The reasons aren't subtle. Doing it manually means there's always a step that you might forget. Doing it manually means the build environment is your machine, with whatever happens to be installed on it at that time. Doing it manually means a version of you 6 months from now in a hurry on Friday afternoon can do something that you really wish past you had made impossible. Safia Abdallah came on the show earlier this season. She's at Warp now, working on agentic developer tools, but at the time, she was a principal software engineer at Microsoft's ASP.NET Core team. She told a story about her second internship, where she accidentally pushed an in-progress feature straight to production. The infrastructure made it trivial to do so. She tried to fix it before anyone would notice, but she didn't. She ended up with a post-it note from the CTO on her monitor when she got back from lunch. And the line she landed on when she was telling this story has stuck with me.
It's not really an indictment of the engineer, it's an indictment of the infrastructure that is set up to support deployment.
That's the principle. The point of all this isn't to be a more careful engineer. The point of this is to build infrastructure that doesn't need you to be a more careful engineer. Past you can't make certain mistakes impossible by trying harder. Past you can make them impossible by automating them away. You need automation. You need a pipeline. You need somewhere outside of your own laptop that knows how to build, test, and publish the package in a way that is the same every single time. In 2017, GitHub Actions did not exist as a public product. That sentence is wild to say out loud. It feels like a sentence about a different industry, but it's true. For .NET open source projects at the time, you had a small handful of options, and the one that most of us reached for was AppVeyor. So that's where OwaspHeaders.Core started. The first appveyor.yaml file landed in the repository on the 25th of July 2017, 2 days before the first blog post in the middleware series went up. So this pipeline genuinely predates the package itself. I remember the first green build. I really do. There's a particular feeling the first time you push a commit or watch a service somewhere else in the world, pick it up, build it, run the tests, and report back green, that you don't get from any other part of programming. It's the moment where the project stops being a thing you have to manually keep alive and starts being a thing that can keep itself alive while you sleep. AppVeyor served the project well. It served it for about 4.5 years. Then, on the 8th of April in 2022, the appveyor.yaml file was deleted from the repository. On the same day, 2 new files appeared inside of .github/workflows. One was .net.yaml, the other was release.yaml. The build had officially moved to GitHub Actions. Same day, out with one, in with the other. The reasons for the move were pragmatic, not philosophical. The code already lived on GitHub. Actions had reached a point where it was a credible replacement, and there's a particular kind of operational tax you pay when your CI and your source control are different services from different vendors with different account systems, different incident pages to watch when something breaks. Folding everything into one provider made sense. I'm not going to walk through the YAML. That's not what this part of the episode is for. If you want to see the pipelines, they're public on GitHub, and I'll link to the repository in the show notes. What I want you to take away is the principle, because the principle is much more important than the choice of vendor. The day you stop publishing your package from your laptop is the day you start running a real package. Until that moment, your release process is whatever happens to be in your shell history. After that moment, your release process is a thing that other people can see, audit, and reason about. Other people, including future you. Other people, including the contributors you'll want to bring onto your project eventually. Other people, including the consumers of your package, who want to understand how it ends up being on NuGet.org. Automation isn't really about saving time. Or it is, but that's not the main thing. Automation is about giving up the ability to make certain mistakes. You can't forget a step that's been removed from your control. You can't accidentally publish from a branch that the pipeline isn't pointed at. You can't ship a version that hasn't been through tests because the pipeline simply will not let you. That's the win. The vendor is an implementation. Now, I want to tell you about a pull request that changed how I think about NuGet packaging. It came from outside of the project, from someone I'd actually known online for years. We'd talked plenty over in the Coding Blocks Slack group, and he'd written regularly into Tabs and Spaces, a now retired podcast I used to host with James Stoddart and Zach Brady. We hadn't met in person. He hadn't until that day touched the code in OwaspHeaders.Core, and the PR he opened lifted the entire project's standard in a single review. The pull request is number 96. The contributor and developer is called Scott Harden. You might know him as the author of ScottPlot, which is one of the most popular .NET plotting libraries. He'd also done 3 episodes of this show with me, and so if any of his voice sounds familiar in a moment, that's why. Scott's PR landed in 2022, and on the surface, it was a metadata cleanup. He'd added the MIT license expression. He'd included debugging symbols, he'd turned on SourceLink, he'd enabled deterministic builds, and he'd designed a proper package icon. 5 things that sounds like a polish pass. It wasn't. It was a complete step change. Let me explain why, starting with the most concrete one, SourceLink.
It is the coolest thing ever that now, if we enable this right combination of things, we can enable a feature called SourceLink, that when you press F12, it lets you jump not just into the functions of your own code, but you can jump into the source code of a NuGet project that you're using.
Think about what that gives the consumer of your package. A developer using OwaspHeaders.Core can press F12 in their IDE, and instead of getting a decompiled view of the DLL, they get the actual source code from the actual GitHub repository at the exact commit that produced that version that they have installed. They can step through it, they can read the comments, they can understand what's happening. That isn't a cosmetic feature. That's a fundamental shift in the relationship between you and the people using your code. Your package goes from being an opaque box that they have to trust to a completely transparent one that they can verify line by line. Deterministic builds work in the same spirit. They mean that if anyone else, anywhere, downloads the source code from the same commit and runs the same build, they will get a byte-identical copy of the package that's on NuGet.org. No surprises, no, well, it worked on my machine and it produced this DLL. The same source produces the same output, always. Symbols and the license expression round it out. Symbols let your users debug into your code from their production diagnostics. The license expression, that's the SPDX format, which is a small structured language for describing exactly which license your package ships under, is machine readable, which means it survives every tool, every dashboard, every legal review process that wants to understand what they're allowed to do with your code. And none of these are cosmetic features. All of them are trust signals. And here is the thing about how this PR got into my project in the first place.
These type of code contributions are just unique, and I bet a lot of maintainers would really benefit from having pull requests like this show up in their inbox. And even if they don't merge it, even if they don't like the logo exactly, it can start a conversation that can lead to possibly something that might be a better fit for the project.
Scott knew more about modern NuGet packaging best practices than I did at this point. He could have written me an email. He could have raised an issue. Instead, he opened a pull request that fixed the things and explained the reasoning, and gave me the option to merge it or to push back on any individual piece. That is the spirit of open source done well. If you ever spot something in an open source package that could be improved, even if it's just metadata, just the documentation, just the package icon, consider raising the PR. Those contributions matter more than the maintainer is going to be able to tell you in the moment. But, and this matters more now than it ever has, read the contribution guide first. Read through the code to understand the conventions. Match the format, the design, the philosophy of the project before you write a single line. A lot of open source maintainers right now are cutting back on external contributions because they're spending more time politely declining drive-by PRs that look plausible but don't fit. Often that's because the contributor has asked a coding agent to fix this bug or add this feature without ever asking the agent to read and understand the code base first. Don't be part of that signal. Scott's PR worked because it was the opposite of that. He understood the project well enough to know exactly what was missing. The diff explained the reasoning. The conversation was already done by the time I looked at the code he'd written. That's the bar that you have to hit. Now, there's one more thing that Scott has said on an earlier episode that has grown even more important since.
And the day that I realized you can just put arbitrary DLLs and NuGet packages, that's when it really clicked for me that, wow, like security is a thing. You can't just be installing random NuGet packages.
Scott said that in December 2024. 18 months later, 15 days ago as I'm recording this, Tanstack published a post-mortem about what happened to them. The Shai-Hulud worm had gotten into 42 of their NPM packages and pushed 84 malicious versions in a 6-minute window. The attack chain ended with malware reading the /proc/PID/mem on a GitHub's Actions runner, stealing an OIDC token and using it to publish to NPM directly. The token was never typed by a human. It was extracted from process memory. And the line from their post-mortem that I cannot get out of my head is this: no internal alerting. We learned about the compromise from a third party. Now, that was NPM, not NuGet. And that is the point. The .NET ecosystem has not been hit on this same scale. Yet. Which is exactly why everything I'm about to say in this next section is not theoretical hygiene. It's the difference between being Tanstack on the 11th of May 2026 and being someone who can prove to the world that their package came from their source code built by their CI with no hands in the middle. This is not a nice to have anymore. That's the price of being trusted. You know that moment when a technical concept finally clicks? That's what we're all about here at the Modern.NET Show. We can stay independent thanks to listeners like you. If you've learned something valuable from the show, please consider joining our Patreon or buy me a coffee. You'll find links in the show notes. We're a listener-supported and, at times, ad-supported production, so every bit of support that you can give makes a difference. Thank you. What does it actually look like to take supply chain seriously in a NuGet package in 2026? Let me walk you through what OwaspHeaders.Core does now, and then I'll come back to the principle behind all of it. The first thing is build attestations. These were added in version 9.5.0. An attestation is a cryptographic record produced by the CI pipeline at the moment it builds the package that says, this exact NuGet package file came from this exact commit in this exact repository built by this exact workflow on this exact runner. It's signed by GitHub's infrastructure. It's verifiable by anyone, after the fact, with a single command. You can take the NuGet package off of NuGet.org right now and run a verify command, and it will tell you whether it matches the attestation or not. That is what proof of provenance looks like. It's the answer to the question, how do I know that this package came from where it claims to come from? The second thing is the OpenSSF scorecard. The scorecard project, run by the Open Source Security Foundation, runs a battery of automated tests against your repository, looking for things like whether your branch protection is sensible, whether your dependencies are pinned, whether you sign your releases, whether you have a security policy. The score is public. Anyone can look at it. And the workflow that produces it runs every week on a schedule, so the data stays fresh. Alongside the scorecard, the project carries the OpenSSF Best Practices Passing Badge. As of this recording, the score is 96%. It was added on the 20th of November, 2024. Both links are in the show notes. The third thing is CodeQL, an automated static analysis tool from GitHub. It looks for known patterns of vulnerable code in your code and flags them. The CodeQL workflow runs on every push, every pull request, and on a weekly schedule. So even code that hasn't changed gets reevaluated against newer security rules over time. Now, here's the bit I want you to notice. When the migration from AppVeyor to GitHub Actions happened in April 2022, the project had two workflows, the build pipeline and the release pipeline. That's it. Today there are 7. Build, release, CodeQL, OpenSSF scorecard, the documentation site for the GitHub pages, a code coverage commenter that posts coverage reports onto pull requests, a changelog sync that keeps the documentation site's changelog in step with the root one. 2 became 7, over about 4 years. And the reason there are 7 and not one giant mega workflow is something I want you to take with you if you take nothing else from this part of the episode. 1 workflow, 1 concern, 1 permission scope. The build pipeline only needs read access to the repository contents. The release pipeline needs the write attestations permission and the OIDC token to authenticate to NuGet.org. CodeQL needs the security events write permission. The scorecard needs a different kind of token altogether. The coverage commenter needs to be able to write pull requests. Changelog sync needs to be able to write to the repository contents, but only on a very specific path. If I'd bundled all of that into one workflow, that one workflow would have needed every single one of those permissions all at once. And anything that compromised the workflow file or any third-party action called into it would have inherited that entire keyring. Splitting them up means that if one workflow ever gets compromised, the blast radius is bounded to the permission for that specific workflow. The build workflow can't push to NuGet.org. The scorecard workflow can't write to the repository. The pages workflow can't see your secrets. Each one is small on purpose. Permissions are like keys. Fewer per workflow means less to lose if one of them ever gets compromised. Look, none of this is hard to adopt. Most of it is templates you can copy directly from GitHub's documentation. The bar to look trustworthy is lower than it should be, which means there is no excuse not to clear it. The package has been on NuGet.org for 8 years at this point. There have been 10 major versions. There have been more bug fixes, more dependency bumps, and more documentation updates than I want to try and count. Maintenance, after the first year or two, becomes less about code and more about communication. Let me walk you through 4 moments from the issue tracker that I think capture the shape of it. The first one is issue number 51. Somebody opened it to point out that the middleware was wrapping URI values inside of the content security policy header in quotation marks. Quotation marks that, per spec, should not have been there. The user was right, the middleware was wrong, and Chrome, and this is the bit that genuinely humbled me, had been silently fixing the mistake in the background without raising an error, so I had never noticed. I fixed the bug, thanks to the person who reported it, and started building a stronger habit around reading specs end to end instead of relying on the browser to forgive me. The bug report wasn't just a bug report, it was free education. The second one is issue number 170. Someone opened it asking for support for the CSP Report To directive. The initial request was a little off. The way they described the syntax wasn't quite right, so I asked for more context. They came back, refined the request, and between the two of us, we ended up with a design that was way better than either of us would have produced on our own. That's a small example, but those are the conversations I value the most. Both parties leave the issue knowing more than they did when it started. The third one is issue number 168. Somebody asked whether the middleware could expose its configuration value feature flags, so they could toggle individual headers on and off at runtime without redeploying. It's a reasonable thing to want, but that's not what the middleware is for. The configuration is deliberately compile time, so the security posture of the application is fixed at the point of deployment, not changeable by a runtime switch that somebody might forget to put back. I closed that issue, I explained why, and I tried very hard to do it in a way that respected the person who'd taken the time to ask. Learning to say no gracefully in writing on a public record is a skill that doesn't get talked about enough. The fourth one is issue number 95. Somebody opened it asking how to allow certain domains. The request as written wasn't clear what they were trying to achieve. I followed up, and I followed up again, and I followed up a third time. Eventually I closed it. Some conversations don't finish, that's just part of the maintenance. None of those 4 interactions involved writing very much code at all. They involved reading carefully, asking good questions, and being willing to say yes, or say no, or to admit, I don't fully understand what you're trying to do. Can you help me? But none of it is a solo act. If you go to the contributions graph on the GitHub repository, and I'll link to it in the show notes, you'll see that the project has been carried by a small, generous group of people who have shown up over the years to make it better. Scott Harden, who you find on GitHub as SW Harden. The others, in no particular order, are CompuFreak345, SP Slane, Miguel C. Printo, Rohit Jha, J. Pinney 1993, Nick Niebling, and Michael M2. And then there's M. Kabi. M. Kabi gets a special mention because they took the OwaspHeaders.Core source code and built a version of it that works inside of Azure Isolated Functions. It's a separate project, OwaspHeaders.IsolatedFunction, and it lives at github.com/mkokabi/OwaspHeaders.IsolatedFunction. I'll link to it in the show notes so you don't have to type that all in. I never built that. I never planned for that. Somebody else took the work, looked at where it didn't reach, and extended it themselves. That's the version of success no one tells you to plan for when you start out. And it might be the single most flattering thing that's ever happened to one of my projects. 8 years across 10 major versions, in the end, less about technical skill and more about everyone who showed up. My name's on the package as the author, but the work behind it isn't all mine. So let me try and land this whole story in one paragraph. What started as a failed pen test in 2016 became a 4-part blog series in 2017. The blog series became a NuGet package. That NuGet package grew a CI pipeline on AppVeyor, then moved to GitHub Actions, then a release process that signs build attestations and proves its own provenance, with CodeQL scanning every commit, and the OpenSSF scorecard scoring it every week, and a passing best practices badge sitting on the repository. 1.7 million downloads. Almost none of that was part of my formal education. I learned every single layer by trying it, getting some of it wrong, putting the wrong version on the internet, getting better next time, and being shown the way by other developers who knew more than I did. Which leaves me with 2 requests, depending on where you are. If you're a developer who has ever thought about turning something you've built into a package, do it. The barrier is way lower than you think. Start with a blog post if that helps. Show your work. That is exactly what I did, and the package grew straight out of that. If you are already maintaining a package, go and look at build attestations, at the OpenSSF scorecard, and at CodeQL. The TANstack postmortem from earlier this month is what happens when those defaults haven't been adopted. Your users deserve to know that they can trust you. And while you're at it, go and listen to episode 159 of this show with Scott Harden. That episode is a deep dive on every NuGet packaging best practice I've touched on in this episode. If you've not heard part 1 of this series, go back and listen. It tells the story of the Pentest, the OWASP project, and the headers themselves. Anyway, thanks for listening. Be kind to yourself, be kind to each other, and I'll see you in the next one. Thank you for listening to this episode of the Modern.NET Show with me, Jamie Taylor. Let me know if you found this monologue interesting or useful. I'd like to know if you did, and whether you'd like me to create more of them. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of this episode. The show notes, as always, can be found at the podcast's website, and there'll be a link directly to them in your podcatcher. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice. Head over to .NETCore.show/review for ways to do that. Reach out via our contact page or join the Discord server at .NETCore.show/discord. All of which are linked in the show notes. But above all, I hope you have a fantastic rest of your day, and I hope that I'll see you again next time for more .NET goodness. See you again real soon. See you later, folks.